In our last lesson, we looked at one-step equations to help learn the algebra steps required to isolate the variable. And today we're going to step it up to two-step equations. So a two-step equation is an algebraic equation that you can solve in two steps. Once you have solved it, you have found the value of the variable that makes the equation true. The steps that you follow will be the same. Okay, the first thing that you will always do in a two-step equation is isolate the variable term by creating a zero pair with the constant. After that, you're going to find the value of one variable either by multiplying or by dividing. Okay, and it's very important to remember your equation's golden rule. You need to keep the equation balanced. And the way that you do that, do to one side of the equation exactly what you did to the other side. To the other side. Okay, whatever you do on one side of the equal sign, you're going to do the same exact thing on the other side. So if we take a look at our first two-step equation, all right, it says in example number 1, 2n plus 8 is equal to 14. Remember that the equal sign splits the equation up into the left side where I see 2n plus 8 and the right side where I see 14, okay? The variable term is on the left-hand side of the equal sign. The variable term is that 2n. All right, the variable term, though, is not alone on the left-hand side. There's this constant of 8 that's on the same side with it. The first thing that we need to do is isolate the variable term by creating a zero pair with the constant. Okay, so since the constant on the left-hand side is a positive 8, the way that I'm going to create a zero pair there is by subtracting 8. And remember the golden rule, do to one side exactly what you did to the other side. Since I subtracted by 8 on the left side of the equal sign, I'm going to subtract by 8 on the right side of the equal sign. Bring your equal sign straight down, and now we'll look at the left-hand side. If we do 8 minus 8, that's my zero pair. So the only thing remaining on the left is 2n. On the right side, if I do 14 minus 8, I get a value of 6. Okay, so that's the value of 2n. 2n equals 6. Now we need to get the value of one variable, either by multiplying or by dividing. Well, this says 2n, which means 2 times n. In order to get just one n, then, I'm going to have to divide by 2. And again, if I do that on the left side, I'm going to do the same thing on the right side. All right, bring your equal sign down. On the left, 2n divided by 2 is 1n, which is the same as n. And on the other side, 6 divided by 2 is 3. So my variable is isolated, and I think it has a value of 3. I'll make sure by doing my check. Remember that for a check, the first thing that you do is rewrite the equation. 2n plus 8 equals 14. I'm going to substitute in my answer. I think n is 3. 2 times 3 plus 8 equals 14. And now I'm going to use my order of operations until I've simplified the left-hand side. So I see multiplying and adding. I'm going to multiply first. 2 times 3 is 6. And then on the left, when I add 6 and 8, I get 14. So 14 equals 14, which checks. So I know that n had a value of 3 in this equation. In example number 2, the equation says negative 3n plus 9 equals 15. Okay, so looking for the variable term, I see it on the left side of the equation. On the same side as the variable term, we see that there's a constant of positive 9. I have to create a zero pair with this positive 9. So the first thing I'm going to have to do is subtract 9 on both sides. Equal sign comes straight down. On the left, 9 minus 9 is 0, leaving us with negative 3n. And on the right, 15 minus 9 is 6. All right, so negative 3n is equal to 6. Now we need to get the value of 1n. Right now, n is being multiplied by negative 3. So I'll have to divide by negative 3 on each side. All right, that's going to give me my 1n on the left-hand side. Negative 3n divided by negative 3 is positive 1n. On the right, 6 divided by negative 3 is negative 2. So I think n is negative 2. I'll make sure by doing my check. Okay, so we rewrite the equation first. Negative 3n plus 9 equals 15. I replace n with my answer, which I think is -2. And now I'm going to use my order of operations. So I'm going to multiply before I add. -3 times -2 is 6. And then when I add 9 with 6, that gives me a value of 15. 15 equals 15, so the check worked, and I know that n had a value of -2. Looking at example number 3, I have n divided by 5 minus 9 equals 3. So again, I see my variable term here on the left side of the equation. There's also the constant -9 on the same side with the variable term. I need to create a zero pair with that -9. In order to make 0, then I'm going to have to add 9 on each side. Bring the equal sign straight down. On the left, -9 plus 9, that's my zero pair. So the only thing on the left now is n divided by 5. On the right, 3 plus 9 makes 12. So now I have n divided by 5 equals 12. I need to get the value of 1n, however. Right now, n is being divided by 5. So to undo that, I'm going to have to multiply both sides by 5. Okay, bring the equal sign straight down. On the left, my 5's in the numerator and denominator can simplify to 1's. So 1 over 1 times n over 1, that's just n. And on the right, 12 times 5 is 60. So I think n is 60. Let's do the check to make sure. N divided by 5 minus 9 equals 3. Replace n with 60 because that's what we think the answer is. All right, use order of operations. I will divide before I subtract. 60 divided by 5 is 12. And now when I subtract 12 minus 9, I do get 3. So 3 equals 3. The check worked. And I know that n had a value of 60. In our next few examples, we're going to incorporate fractions into our equations. And if I have a fractional coefficient, in order to solve an equation that has a fractional coefficient, I'm simply going to multiply by the reciprocal of the fraction in order to get the value of the variable. So looking at example number 9, where it says 3/5 m equals 96, okay, this is just a one-step equation. In order to get the value of m, right now it's being multiplied by 3/5. So naturally, since it's being multiplied by 3/5, you would think I would divide by 3/5 on both sides. But don't forget that when we divide with fractions, again, we actually multiply by the reciprocal of the fraction. And so that's what we're going to do down here. The reciprocal of 3/5 is 5/3. So I'm going to multiply both sides of my equation by 5/3. Okay, on the right, since I've multiplied by a fraction, I'm going to make 96 a fraction by putting it over 1. Okay, let's bring our equal sign straight down. And on the left-hand side, this is going to be really nice. I have a 5 in the numerator and denominator, so those can become 1. I have a 3 in the numerator and denominator, so each of those can become a 1. So it's 1 over 1 times 1 over 1m, which is just m. So our variable is isolated here on the left-hand side. On the right-hand side, I can simplify with 96 and 3. Their common factor is 3. 3 goes into itself once. 3 goes into 96 32 times. So I have to do 32 over 1 times 5 over 1, which is really just 32 times 5, for an answer of 160. M equals 160. In example 11, we have 4/5 a plus 7 equals 39. So once again, this is a two-step equation, and notice that the coefficient of my variable term is a fraction now, okay? Our process isn't going to be any different than any other two-step equation that we've worked with. The first thing that we have to do to get the variable term alone, we have to make a zero pair with the constant, which is a +7. Okay, so the way that we make a zero pair with a +7 is by subtracting 7, and I need to make sure that I do that on both sides to make my equation balanced. Bring the equal sign straight down. On the left, 7 minus 7 is 0, so the only thing on the left now is 4/5 a. And on the left, or on the right rather, 39 minus 7, that equals 32. So now we have 4/5 a equals 32. Now that I have a fractional coefficient, instead of dividing by that fraction, I'm actually going to multiply both sides by the reciprocal of the fraction, which in this case is 5/4. The reciprocal of 4/5 is 5/4. So we'll multiply both sides by the 5/4. And again, I'll make 32 a fraction by putting it over 1. Bring down your equal sign. On the left, look at all the nice stuff. The 5 simplify the 1s. The 4s simplify the 1s. So all of this is just 1a or a. On the right side, 4 and 32 have a common factor of 4. 4 goes into itself once. 4 goes into 32 8 times. 8 over 1 times 5 over 1 is 40. So we think that a is 40. Okay, let's do the check. I'll squeeze it in here. We have 4/5 a plus 7 equals 39. I'm going to replace a with my answer of 40. So I have 4/5 times 40, and I'll put that over 1, plus 7 equals 39. I have to multiply before I add. With the multiplication, however, I can simplify with the 5 and the 40. 5 goes into 5 once. 5 goes into 40 8 times. 4 over 1 times 8 over 1 makes 32. Plus 7 equals 39. And finally, when we do the addition, 32 plus 7 is 39, so it checks. And I know that a had a value of 40. In example number 13, I have 3n minus 2 1/4 equals 7 3/4. So once again, I need to make a zero pair with my constant. Okay, the variable term's on the left. The constant on the left is negative 2 1/4. I'm going to have to create a zero pair by adding 2 1/4. And again, make sure that you do that to both sides. Bring your equal sign down. Negative 2 1/4 plus 2 1/4. Again, that's your zero pair. So 3n is on the left. 7 3/4 plus 2 1/4. Well, that's actually going to be a value of 10. All right, so 3n equals 10 is our equation. Now we need to get 1n. N is being multiplied by 3, so I'm going to have to divide by 3 on each side. 3n divided by 3, there's our 1n. Now, 10 divided by 3, you can leave this as the fraction 10/3 if you would like, or you can change that into the mixed number, which would be 3 1/3. Either one of those is going to be correct. Now, let's go ahead and do our check. Okay, I'm going to rewrite the equation. 3n minus 2 1/4 equals 7 3/4. I'm going to replace n with my answer. Now, when I do this multiplication, I'm going to need to use the single fraction version. So I'm going to substitute in 10/3. So I'm going to make 3 a fraction, 3 over 1, times n, which was 10/3, minus 2 1/4 equals 7 3/4. Okay, I multiply before I subtract. Now notice with the multiplication, I can simplify the 3's down to 1's. 1 over 1 times 10 over 1 is just 10. So this is 10 minus 2 1/4 equals 7 3/4. And now when I subtract, 10 minus 2 is 8. And now when I take off the extra 1/4, 8 minus a fourth, well, that's 7 3/4, which equals 7 3/4. So the check worked out. And again, I know that n was equal to 10/3 or 3 1/3. In our last few examples, we incorporated fractions into the equations, and we can also incorporate decimals into our equations. So looking at example number 15, we have 4m plus 2 3/10 equals 2 58/100. This again is a two-step equation. The variable term is on the left side of the equation. The constant on the same side is a positive 2 3/10. So we need to make a zero pair. And the way that we're going to do that with a positive 2 3/10 is by subtracting 2 3/10. If you did it on the left, do it on the right so that your equation is balanced. On the left-hand side, 2 3/10 minus 2 3/10, that's your zero pair. So 4m is on the left side. On the right side, 2 58/100 minus 2 3/10, that's going to give us 28/100 when we do the subtraction. So 4m equals 28 hundredths, but we need the value of 1m. All right, so that means we're going to have to divide by 4 on each side. 4m divided by 4 is our 1m. 28 hundredths divided by 4 is going to be equal to 7 hundredths. So we think m has a value of 7 hundredths. Let's make sure by doing the check. Rewrite the equation. 4m plus 2 and 3/10 equals 2 and 58 hundredths. Replace m with your answer. We think it's 7 hundredths. And now we'll use our order of operations. Again, we multiply before we add. 4 times 7 hundredths is going to give us 28 hundredths. And now when we do the addition, if we have 28 hundredths plus 2 and 3/10, that will give us 2 and 58 hundredths. So the check works out, and I know that m had a value of 7 hundredths. The equation in question 17 shows a special case, okay? There's actually two different ways that we can solve this equation. So the equation says 2/10 multiplying n minus 3 in parentheses is equal to -10. All right, now if we cover up the equals -10 with our finger and make it look like that, okay, well, notice now this expression looks like what we were doing in our last topic, where in order to get an equivalent expression, we would have to use the distributive property. And in fact, that is one way that we can solve this equation, by using the distributive property. Okay, so if I were to distribute with the 2/10, I would have to do 2/10 times n, 2/10 times n, plus I would do 2/10 times the -3. Okay, and now the only difference from the last topic to this topic is now that it's equal to a number, equals -10. If we go ahead and do our multiplication, 2/10 times n is just 2/10 n. 2/10 times -3 is going to be -6/10, equals -10. And here is our two-step equation. Our variable term is on the left. The constant on the left is a -6/10. To make a zero pair, we will add 6/10 on each side. Bring your equal sign down. On the left, -6/10 plus 6/10 is 0, leaving us with 2/10 n. And on the right, -10 plus 6/10 is going to be -9 and 4/10. Now to get the value of 1n, n right now is being multiplied by 2/10, so we'll go ahead and divide by 2/10 on each side. On the left, 2/10 n divided by 2/10 is our positive 1n. On the right, -9 and 4/10 divided by 2/10 is going to be -47. Okay, so n has a value of -47. So distributing in a case like this, absolutely great idea. That leads to your two-step equation, which we now know how to solve. Okay, another way that we could do this is by treating the stuff in parentheses n minus 3 as our variable term. Okay, so let me rewrite the equation. I have 2/10 multiplying n minus 3 in parentheses equals -10. Okay, now I'm going to treat n minus 3 in parentheses as my variable term. Right now, this is being multiplied by 2/10. In order to isolate what's in the parentheses, I can simply divide each side by the 2/10. Okay, so let's look and see what happens when we divide by the 2/10. All right, on the left-hand side, let me bring my equal sign down. On the left-hand side, if I do 2/10 divided by 2/10, that's equal to 1. So all that's left on the left-hand side is what was in parentheses, which was my n minus 3. And I no longer need the parentheses now, okay, because I've taken away what was going to be distributed. So now I have n minus 3 on the left. And on the right, if you do -10 divided by 2/10, punch that into your calculator, you would get -50. All right, and so now this is just a one-step equation. N minus 3 equals -50. All right, to isolate n, we're going to create our zero pair here. It's a -3, so I'm going to add 3, and we'll do it to each side. Bring your equal sign down. On the left, negative 3 plus 3 is 0, leaving us with n. And on the right side, negative 50 plus 3 equals negative 47. So there it is. Either way, notice I get the same exact answer. So I could easily distribute at the beginning like we showed in method number 1 to get our two-step equation. Or I can treat what's in the parentheses as the variable term and isolate this variable term by dividing each side by that number on the outside of the parentheses, which creates our one-step equation leading to our answer. The choice is yours.